yesterday in 6.8, we were working with our square root graphs, yes? And we talked about these square root graphs having this 0, 0, 1, 1, 4, 2, and 9, 3. But then when we got to A and B, we had all these different transformations to do, right? So let's review, because I think you guys already have it written down. What's this 3 telling me to do here? There's a number multiplied out front. It is a stretch, right? It's either a stretch or a shrink. Because it's bigger than 1, this is a vertical stretch. Okay. What about this plus 2 under the radical? Left 2. Remember, if it's with the x under the radical, it's left or right, opposite the sign. And so this plus 2 is going to tell me to translate my graph left 2. And my minus 4 underneath the radical, or excuse me, after the radical is what I want to say there. Minus 4 is going to tell me to go down 4. Because if we recall from first semester, if it's with the x in the parentheses, under the radical, in the absolute value, it's left or right opposite the sign. If it's at the end, not with the x, it's up or down direction of the sign. Okay, so those are the 3 transformations we have to deal with. Left 2, down 4, that'll be a piece of cake. I'll worry about that at the end. We need to deal with this stretch of 3. Now it's a vertical stretch of 3. So what values am I stretching? If I'm stretching vertically, are those the x's or the y's?
Y.
Those are the y's, right? So when you're doing a vertical stretch, our x values aren't going to change, but our y values will vertically stretch. So, you guys remember that chart we talked about from yesterday? Good values to use for square root. We came up with the ordered pairs 0, 0, 1, 1. What's the next one?
4, 2.
4, 2.
9, 3.
9, 3. And if you recall, we picked these weird x values of 0, 1, 4, 9 because they are numbers I can take the square root of. We decided not to use 2 and 3 because I can't take the square root of those. Now, a vertical stretch of, what was it, 3? Means I'm going to take my y values and multiply by 3. So kind of like what I showed on the previous one. I'm going to multiply my y values by 3. And I'm going to write those new y values down. So we're going to see what we get with 3y. Okay. 0 times 3 is 0. 1 times 3 is 3. 2 times 3? And 3 times 3? 9. Now, when we go to graph this stretch of 3, remember we're going to use our original x values that we did not change, and we're going to use our new y values. So instead of using 0, 0, 1, 1, 4, 2, and 9, 3, we're going to use 0, 0, 1, 3, 4, 6, and 9, 9. So we're going to take those x and y values and we're going to graph them. And then after I graph them, what's the other part I'm still going to have to do? We're still going to have to move our points left 2, down 4. So I'm going to write graph here, and then I'm going to say, then move left 2, down 4. And it's not that you have to write this out. I'm just trying to give you guys some notes that you can put in your notes. So when you look back at this later and say, what the heck did we do? You have an idea. Okay, are we ready to graph those points? Or maybe you already did. Okay, so instead of 0, 0, I'm going to graph 0, 0. That one doesn't change. Instead of 1, 1, I'm going to graph 1, 3. So I'm going to go right 1, up 3. Instead of 4, 2, I'm going to graph 4, 6. So I'm going to go right 4, up 6. And instead of 9, 3, I'm going to graph 9, 9. Am I done? No. Right there, I did my graphing. I graphed those original points. But, so that is the stretch. Now, as you look at that, does that look a little wider than what we were doing yesterday? Definitely looks a little wider, because yesterday it just looked like a regular half of a parabola. This is half of a parabola, but it's much more stretched up. Each of those points, we're now going to take them and move them left 2, down 4. And if you can do that all at once and not have to graph the extra set of dots, that's your choice. So I'm going to take 0, 0, and I'm going to take it left 2, down 4. So I end up at negative 2, negative 4. I'm going to take 1, 3, and I'm going to go left 2, down 4. So I end up at negative 1, negative 1. I'm going to take 4, 6, and go left 2, down 4. And I end up at 2, 2. Then I'm going to take 9, 9. I'm going to go left 2, down 4. And then I think I end up at 7, 5. Yeah. These new dots, so for me, my blue dots, are what I'm graphing then. It's not that you'd even have to have the red dots on there. That's all kind of a personal choice. Make sure you connect the correct dots. As I reminded yesterday, remember the beginning dot, what was it, 0, 0? That's a point. It's not an arrow, it's a point. As you go off to the right, you do extend past the final dot, and that is an arrow, because our graph does go on indefinitely to the right there. Okay, questions there? We're ready to talk about some cube roots then? As I think someone asked yesterday, I think it was this class, yes, I did change these a little bit. Because if you look at what you have there, do you know anything about what a cube root graph looks like? No, we learned yesterday about a square root graph, but here's the catch, guys. A cube root graph doesn't look anything like a square root graph. It looks totally different. So, before we can graph something with all the different things happening, we need to talk about just, okay, what about a cube root graph? What does y equals the cube root of x? So in place of example 4a, I have gotten rid of the other one, so scribble it out, and you're going to do y equals the cube root of x now. As we just said, you guys don't know what y equals the cube root of x looks like, right? So, Google it. Nice answer. But we're in the middle of math class, so we're not going to Google it. What are we going to do to try and figure out that graph?
Listen to you.
XY chart.
Okay, you're going to listen to me guide you through an XY chart.
Yeah.
Okay? Yesterday, we picked values of 0, 1, 4, and 9. Do we want to use those same values?
No.
No, we picked those values yesterday because we could take the square root yesterday. I need values I can take the cube root of. Now, I'm still going to like, what's the first one I'm still going to like?
0.
Can you take the cube root of 0? Yeah, the cube root of 0 is 0. So I do like 0. Do I like any of the others? Can I take the cube root of 1? Yeah, 1 times 1 times 1 is 1. So I still like 1.
I'm assuming it's going to be a negative.
Okay. We'll talk about negatives here in a moment. If we're going for our next positive value, 8, because what is the cube root of 8? 2. And if you look on that blue paper, the first perfect cube I have there is 8, isn't it? So the cube root of 8 is 2. If we keep going in positives, what do we have to go to next? 27. Do you feel like graphing the cube root of 27?
Pretty low.
I mean, the cube root of 27 is 3. That's easy, but do you want to graph 27? No. So usually I just stop at 8, 2. Now, I kind of made it obvious, didn't I? What do we need to consider with a cube root? Negatives. With square roots, we didn't do negatives because you can't do the square root of a negative. It's not an option. With cube roots, can we take the cube root of a negative? Yeah. I heard, what was the first one you guys said? Negative 1. What's the cube root of negative 1? Negative 1, because negative 1 times negative 1 times negative 1 is negative 1. What else am I going to ask for? Negative 8. What's the cube root of negative 8? Negative 2. Because negative 2 times negative 2 is 4, times another negative 2 is negative 8. Okay, guys. You know, in the square roots, you have that 0, 0, 1, 1, 4, 2, and 9, 3. Here's your cube root master list. Okay? Anytime we see a cube root problem, which, honestly, I'm going to stick more with square roots, but it's still good to look at cube roots. We're going to use that. So let's graph it and see what it looks like. Negative 8, 2 says I'm going to go left 8, down 2. Negative 1, negative 1. Left 1, down 1. 0, 0. Right 1, up 1. And 8, 2. Right 8, up 2. Okay. Definitely not half of a parabola like the square root was, huh? Okay, so it does do kind of a zigzag thing, or curve thing. Looks kind of like that. I'm not the best at drawing these, but you get the idea, right? It's not that it's a straight line in the middle. Those three pieces just kind of form our middle portion. And keep in mind, guys, this is the y equals the cube root of x. Well, the cube root of x is going to be the inverse of y equals x cubed. Do you remember what y equals x cubed looks like? You remember this one? That's y equals x cubed. We've run across it on occasion. We haven't done a whole lot with it, but we have run across it on occasion. That's y equals x cubed. So x cubed. So what happens when I reflect that across that diagonal line? It becomes this right here. Okay, so not that you have to have this on there, but you've seen that graph just going a different direction before.
I was like, I knew it looked familiar because we had done a little bit with it. Like,
Yeah, you've done a little bit with the cube root,
Yeah.
or excuse me, the cube, x to the third. So now b I also changed, right? Unless you really want to get real fancy with what's underneath there, but I'm going with the basics. Cube root of x minus 5. What do you need to know?
Goes down 5.
Okay, the minus 5 at the end, not under the radical, tells me that this graph is going to be x cubed, and then it's going to translate down 5. Individual choice here. Are you someone you want to put the original dots on and then you want to count them all down 5? Are you someone that you would rather just move them as you put them on? It's up to you. I'm going to put my original dots on, being the teacher. I'll be honest, if I was doing it on my own, I probably wouldn't. But so if I put my original dots on of 0, 0, 1, 1, 8, 2, -1, -1, -8, 2. Those are the original dots, right? This set of ordered pairs in the middle, those are my original dots. That's the cube root of x. What are we doing on this particular problem? We're translating down 5. So take each of those dots and move them down 5 from where they're at. I know what I like to do here is I like to take my center dot down 5, and then I like to count from there is my trick. So like if I take that center dot that was at 0, 0, and I go down 5, I'm now at 0, -5, yes? I kind of then like to think, okay, from those points I need to go over 1 up 1 and over 8 up 2. And I need to do the same thing the other direction. So I could go over 1 up 1, and I could go over 8 up 2. That's the equivalent of just dropping those other dots down 5. I'm also going to do the same thing here. I'm going to go left 1 down 1 and left 8 down 2. And if you count, all those dots are 5 below the original dots. Or points, I should say, I guess. And then connect them to make the graph, right? You guys ready for example 5? I think the last 2 or 3 problems in homework are like these two, if I recall from my morning class.
They also asked for
Huh?
that.
And I'll talk about that during work time. I forgot until my morning class asked that there is, I think, one that talks about a domain range. And probably the easiest thing for me to do is to go through that one with you. Because I think there's just one is what my morning class told me. So when we get to work time, which we crazy thought we're going to have some work time today, I'll take you through that one. Okay. Okay, let's look at example 5. How can you rewrite y equals square root of 9x plus 18 using transformations? And then describe the graph. I don't know about you guys, but I can do stuff with these graphs if it's square root of x. If there's square root of x and there's something added, subtracted, multiplied out front, I can do something with square root of x. But this is square root of 9x plus 18. So it's not a good form right now. My question to you, what do you notice about 9x plus 18?
Take the square root.
I can take the square root of 9, but because it's 9x plus 18, I can't do that in this form. So hold that thought. We'll come back to it. What do 9x and 18 have in common? Do they both have a factor of 9 in them? Okay. So he said they both divide by 9. I'm going to use it as a factor. So first thing I'm going to do is I'm going to rewrite this. Oops. Still under the radical, I'm going to factor out a 9. So think GCF here. It's been a while, I know. But if I, under the radical, put a 9 first, 9x divided by 9 leaves me with x, plus 18 divided by 9 leaves me with 2. So all I've done so far is rewrite that by factoring out the GCF of 9. Earlier, I vetoed Lily's idea of taking the square root of 9 because it was 9x plus 18. Because there was a sum under there that 9x was part, that 9 was part of, we couldn't do it. But now there's a difference. Now it's 9 is by itself, and it's 9 times this quantity. Can we take the square root of 9? In this form, I can because it's a factor. So what's the square root of 9? 3. And where's that 3 going to go? Outside the radical. So it's going to be y equals 3 times the square root of x plus 2. there's the first part of this answer. When it says, how can you rewrite this using transformations? I just rewrote this. Are there some transformations you can identify here now? Excuse me. What's that 3 tell me to do? What's that 2 tell me to do?
Vertical stretch. Factor.
Vertical stretch by a factor of 3. And go where?
Left.
And go left 2. Translate left 2, yes? Now, one quick question before I start writing this out. What graph is this being done to? What is my base graph here? Y equals the square root of x, okay? And that's kind of important sometimes because the idea is if you describe this graph, I should be able to take your description and draw the graph. If you don't ever tell me what the original graph is, I can't do that. So, I'm going to start my description by stating what graph we're talking about. So it's the graph of y equals the square root of x. Is stretched vertically by a factor of 3 and my official mathematical word for moving left 2 is translate left 2 units. I know I don't do a real good job of staying out of the way when I write it, but that's why I kind of try and read what I'm writing. So, the graph of y equals the square root of x, stretched vertically by a factor of 3, and translated left 2 units. And translate left 2 units is what I wrote. That is your description. I discovered this morning. Obviously, you're not going to write that out. They had 6 choices to pick from. So it's a matter of getting the right choice that has the right stretch as opposed to shrink, left versus right, up for, just all of that stuff. So. Shall we try B real quick? And then you'll have some work time. So how can you rewrite y equals the cube root of 8x plus 32 minus 2? Well, what do you notice under that radical? 8x and 32? Yeah, they both have a common factor of 8. So let's rewrite this. Y equals the cube root of, and underneath there I'm going to factor out the 8. When I divide both of those pieces by 8, what am I left with? Should be an x plus 4. 8x divided by 8 is x. 32 divided by 8 is 4. Don't stop there, though. What's the one other step I can take in rewriting this? Yeah, luckily it's a cube root, not a square root, right? It'd be difficult as a square root. But we're going to do the cube root. So the cube root of 8 is 2. So it's going to be 2 times the cube root of, there's still an x plus 4 in there, and there's still a minus 2 out back. Okay, got a description? Can you do it this time? The graph of what? It's the graph of y equals the cube root of x. What's being done to it? What's my 2 out front do?
stretches.
Yeah, it stretches it. Know whether it's a stretch or shrink, folks. So stretched vertically by a factor of 2 and translated where? Plus 4 tells me to go left 4. Minus 2 tells me to go down 2. So translated left 4 and down 2 units. Okay, guys. Homework for this lesson's actually turned out to be pretty easy from what I've seen. You've got 10 homework problems. You definitely have some work time. And I will pull mine up on the screen so I can maybe help you with a couple of the ones that I've already heard complaints about. Your homework, of course, in case you've missed it, lesson 6.8 in Math Excel.